We're about to look at question number 5 from the 2025 AP Calculus AB exam. This was not a common question with the BCs. This was only on AB. And let's get to work. I have not read the question yet. All I've done is I've only looked at the questions closely enough to know what was and was not a common question. So you get to see me process this problem in real time. I will possibly make a mistake, and if I do, please point it out in the comments below, which people love pointing out other people's mistakes. And so I'm sure you didn't need that prompt. So here we go. Let's see what we have. Two particles, H and J, are moving along the x-axis. Good, particle motion. Yay. That is an ugly function. Okay, the position of particle H is given by that. The velocity of particle J is given by that. Man, that H position is ugly. All right, find the velocity of particle H at time 1. And so the velocity of particle H, we will need the derivative of its position. And so I'll make a note to myself that x sub h of t is e to the t squared minus 4t. And then the velocity of particle J, and they used a capital J, not that it matters, is given by 2t. Ooh, I see a U substitution problem coming up. That is primed for U sub. They're going to ask you for the position at a given time, I bet you. Do we have an initial position for J? Not yet. All right, so question A is asking for the velocity of particle H. So the velocity of particle H is the derivative of the position. Man, this notation is weird. X prime. You must make the connection to X prime. You can't just write V of t. You need to connect it to X prime. And that derivative, this is a chain rule. The derivative of e to the stuff is the derivative of the stuff times your original expression. So there is h, the derivative of x of h, and we want the velocity at time 1. And so the velocity of h at time 1, we will simply plug 1 into that expression. That'll be 2 times 1 minus 4 times e to the 1 squared minus 4 times 1. And that is an acceptable answer. If you want to show off, 2 minus 4 is negative 2, and 1 squared minus 4 is negative 3, but there's no value in simplifying that. So I'm going to leave it at this ugly answer over here, and I'll just put a line through that. So if I made a mistake, it won't be held against me. Okay, so number B, during what open intervals are particles particles H and J moving in? Oh my goodness, this is a tricky one. Oh, we're due for a tricky one. I don't think the first several were really painful. And this one's not super crazy. We want them moving in opposite directions, and that is going to be based on the velocities of those functions. And so I'm going to start by finding when the velocity of particle H is equal to 0, and that's going to be when 2t minus 4 times e to the t squared minus 4t is equal to 0, and that's going to happen at t equals 2, and you should know that exponential functions, e to any exponent, is always positive. That expression will always be positive, which is going to make this a little bit more convenient. Now, number lines are invisible to AP readers. However, I do believe that they are wonderful organizational tools. And so this is the velocity of particle H with the velocity of 0 at 0. I'm going to plug in maybe 0 for t and 3 for t. And I'm simply going to make the note that velocity of particle H at time 0 would be negative 4 times something positive. That is negative. And the velocity of particle H at time 3 is going to be 6 minus 4, which is 2 times something positive, which is positive. And so I now know that H is traveling left from, do we have a certain interval? 0 to 5. Okay, from 0 to 2, and right from 2 to 5. I now need to do the same analysis for particle J, and we want them moving in opposite directions. That means their velocities need to have opposite signs. So number C, this isn't C. I need the velocity of particle J to equal 0. That's going to be when 2t times t squared minus 1 cubed is equal to 0. That's going to happen at t equals 0, 1, and negative 1. However, since we're on the interval 0 to 5, while I do have a 0 velocity at 0, negative 1, and positive 1, The context of this problem makes this a little bit convenient because I really don't need to worry about anything left of 0. I'm only going to concern myself with values that are on the interval specified. So that gives me v, the velocity of j at time 1/2. That's my test point here. That will be 2 times a half, that's positive. 1/2 squared minus 1 is negative, so that will produce a negative result from 0 to 1 and probably positive after 1. So the velocity of j at time 2 would be positive. Okay, and now for my conclusion, we need those objects, we need them to move in opposite directions. That's going to happen from 1 to 2, because if you overlay these two velocities, particle H is still traveling left until we get to 2. However, particle J starts moving right after t equals 1, and so they will move in opposite directions on the interval 1 to 2 because the velocities of those two functions have opposite signs, and I have all the work to support that statement. So the particles move in opposite directions on the interval 1 less than t less than 2 because their velocities, the velocity of h and the velocity of j, have opposite signs. On that interval 1 less than t less than 2, and I believe that's sufficient. I've used up a lot of space already on this one. Okay, so there's A and B. Let's look at C. It can be shown that the velocity's derivative, J's velocity's derivative at 2 is positive. Is the speed of the particle increasing, decreasing, or neither at time t equals 2? Okay, that's going to be pretty convenient. So speed increases when velocity and acceleration have the same sign. Speed decreases when velocity and acceleration have opposite signs. And therefore, that may have helped you on one of your questions there. Were you listening?
It is, but I already put it down.
Okay.
So.
Not a student taking a quiz in here.
Yeah, I said both are either positive or negative,
Yeah.
so there's
Okay,
some sense.
you're there. Okay, so we need to figure out what is the velocity of particle J at time 2 and the velocity of particle J at time 2. If you want to be really detailed, I can say that's 2 times 2, that's 4, times 2 squared minus 3 cubed minus 1 cubed. That is a positive value. The acceleration of particle J at 2, which is the derivative of the velocity of particle J at 2, and they just outright tell you that that is a positive value, and therefore I can say that the speed of particle J is increasing because acceleration and velocity have the same sign. So the speed of particle J is increasing at t equals 2 because the velocity and acceleration of particle J have the same sign at t equals 2. And I have written work to support that claim. All right, I'm going to draw some barriers here. My work is all kind of there. And I'll put one here. Oh, geez, that was bad. Put one here. All right, what in the world are you doing? Don't do that. My wife's calling me. I'm wasting way too much time trying to separate my work here. I'll do a hand-drawn line. Okay, now on to D. Particle J is at position 7 at t equals 0, so the position of particle J at 0 is 7. Find the position at particle at time 2. I told you, I predicted this question. equals what? And I predicted this when I saw the velocity was easily integrable. And so my position at particle 2 is 2. No, it's not. It's unknown. It's unknown. So my position of particle J at 2 is, it's going to be your initial position of 7 plus, and then the change in position, your displacement, would be the integral from 0 to 2 of the derivative or the velocity of particle J. They call it velocity. Like that, which would be 7 plus, as a matter of fact, I think I'm going to do this, my initial position of J at 0. And then that will be 7 plus the integral from 0 to 2. And I will write my expression for the velocity. That's 2t times t squared minus 1 cubed. 2t times t squared minus 1 cubed dt. And now let's work out that antiderivative. And it is a good u subber. Normally I wouldn't do this in great detail, but I will this time for clarity. So u would be t squared minus 1 du. du would be 2t dt. I see my du, I see my u, so that's going to turn into, I'm going to do this on scratch paper over here, the antiderivative. That turns the integral into the antiderivative. 2t dt will be replaced with the du. T squared minus 1 will be replaced with u. And I like to convert my limits as well. These values of 2 and 0 are values of t, and when you convert those, my u value when t is 0 would be 0 squared minus 1. That's negative 1. So my lower limit becomes negative 1. My u value when t is 2 squared minus 1, which is 3. And now I can finish this definite integral without ever going back to t's. And so the antiderivative is u to the 4th over 4. Evaluated from negative 1 to 3. That's 3 to the 4th over 4 minus negative 1 to the 4th over 4. And that is going to be injected way back over here. So 7 plus, and the answer to that antiderivative is 3 to the 4th over 4 minus negative 1 to the 4th over 4. And I am leaving my answer exactly like that. No benefit whatsoever in cleaning that up. Yeah, that's it. We are done with question number 5. That one took a little bit longer than the others, I think. What's my time on this one? Yeah, 12 and a half minutes. That's a big one. All right, on to question number 6. And again, if you saw any mistakes in all of my work, or if you have any questions, post them below, and I'll respond at some point.